Hello, hi there, my lovely stats enthusiasts. Or if you're not yet a stats enthusiast, perhaps you're in a stats class and you need a bit of help, and welcome to you too. Or maybe you're just bored and stumbled by this screencast by accident, but it doesn't matter. A hearty welcome to everyone. My name is Bronwyn, and I'm a lecturer at CPUT. I teach applied stats predominantly to postgrad students, and I'm making a series of videos to help anyone who wants to understand a bit more. If you want to contact me, you could use this email address, and I welcome any feedback that you might have on any of the videos that you see that I post. But so without any further ado, let's get started. So, statistics. My favorite thing is statistics. Well, one of my favorite things is statistics. And without us realizing it, every day we are bombarded with data. And every day without us realizing it, even in a very primary form, we actually do a bit of statistics. Now, I bet you many of you watching this clip are actually students. And without you even realizing it, you calculate your marks and you do stats on your marks all the time. Students are excellent at that. So you can't avoid it. We see numbers and numerical graphics all the time. And so what stats does is it helps us to convert these numbers into useful information. We see the numbers, but it's not always easy to understand what these raw numbers mean. So statistics is a science that helps us deal with the collection, the calculation or the tabulation in a systematic way of numerical data. It's a collection of mathematical techniques that helps us to analyze data and present data. In simple terms, it helps us to communicate, and it helps us to convert numbers and communicate it so that we can make good decisions. That's why we're actually using stats. It helps us to condense data, and we can present it to people who are interested in certain phenomena. And today, statistics is central to almost all scientific disciplines. We can't get away from it, so we might as well just join the party and transform data into forms that can be understood and communicated by everyone. So in my next slide, first I've got to say thank you to Vadlo for letting me use their cartoon. And this is a very cute cartoon, I think, which says data doesn't make sense, and that's why we have to resort to statistics. So it would be impossible to measure each and every element. If you wanted to know something about a worldwide phenomena, it's practically impossible to measure each and every element that you find in the world. So you know what we do? We take a smaller group and we can make a good estimate of what it is that we see happening in the smaller group, and we can project that on a larger group, and that helps us to make good decisions going forward. So what I'm going to do before we get into the nuts and bolts of statistics, I'm going to tell you the story of statistics, just a little bit of background to ease us in gently. And statistics, the first thing that's important for us to know is there are two branches of statistics. The first branch of statistics is descriptive statistics. Now, when I started working a few years ago, the people that I worked with would speak about stats all the time. Let's do your stats. And now I only realize that was only one part of stats. Many people think that descriptive statistics is all that there is to stats. And descriptive statistics is actually really what the word says. It describes a phenomenon. So examples of this descriptive statistics is graphs and bar charts that we see. If someone tells us what the average is, and I'll go into a little bit more detail as to what the average, the mean, and the median and the mode is in later screencasts. But basically, there's a form of statistics that just within a snapshot, it can tell you what is happening in a particular situation, in a particular environment. And that statistics is called descriptive statistics. I'll read there. The purpose of descriptive statistics is to summarize and display data so that we can quickly obtain an overview, and it helps to communicate, to see the bigger picture quickly and easier than what it would be to see lots of numbers that just doesn't make sense. So it has 3 basic steps, which is organize the data, then we summarize the data, and there are statistical tools that we can use to display the data. The next type branch of statistics is inferential statistics, and that only takes place after you've done the descriptive statistics. Once you have already described a phenomena using statistical techniques, then we use that data or that information to make projections or claims about something that we expect to happen in that situation that we've just analyzed and that we've just presented descriptive statistics on. And to be able to do this, we need to understand the 2 basic terms, which is a population, and a population is all the possible elements that is in a particular group that is of interest to us. And as I mentioned earlier, sometimes it is practically, in fact not sometimes, most of the time, it is practically impossible to measure each and every element in a population. So what we do is we collect a smaller group, which is a sample. The sample is a subset of the population. So the difference between descriptive statistics and inferential statistics is descriptive statistics only reports on what is observed. So we take a sample and we can report on what is observed. What do we see in that smaller group? And then we know that this smaller group should represent a larger group. And we use the information that we've obtained on the smaller group and we make a projection on the larger group, which is the population. And now, at this point, it's very important that I add that ethics is critically important. It really is important because as you get better and better at doing statistics, you are going to be able to do very fancy things like hypothesis testing, and you're going to do things that will probably impress lots of people, and they're going to think that you're really smart. They're going to realize that you're really smart. But as a statistician, you can bias what you do. You can, if you do not work properly, if you do not select samples that's representative of the population, and sometimes only you will know. If someone is not on top of the game, then only you will know about this. But it is important. And if you come from a area that you want people to believe you, in fact, all of us should want that. We should realize that we have the responsibility towards those people that we are reporting to be honest and trustworthy. And so ethics is very, very important. We need to take responsibility. We need to make sure that the sample that we gather is as ethically selected as possible. Okay, so on the topic of descriptive statistics and inferential statistics, here's a couple of exercises, and you can pause the video now, and if you're with certain people, if you're a group of people, you can discuss these examples, and I will go through each of them with you after you've paused the video and you've discussed it, and we can think for ourselves now and try and work out, are these examples of descriptive statistics or inferential statistics? Dum. So we're back again, and let's look at those exercises. Number 1 says the number of males in a stats class and the number of females in a stats class. So if we were to walk into a stats class and we were to count and report the number of males in the class, and then count and report the number of females in the class, would that be inferential or descriptive? I think that would be descriptive, because we'll just be describing a phenomena, or we'll just be describing what we see. And we go on to number 2, that is using the gender distribution of one stats class. Okay, so we've done the gender distribution in exercise 1. And we use that to estimate the gender distribution of the whole university. Now, would that be descriptive or inferential? I think that would be inferential. Of course, yes, it'll be inferential because we're using information from a smaller group, which we believe is representative, to make an inference about a larger group, which is the whole university. Right, number 3 is an interesting one. The average class mark is 75%. So the average would simply be descriptive. What we basically did is we measured and we are reporting. We are not making an inference or a projection on what is going to happen this year or next year or the year after that. If we had the average mark and we did further testing, like an hypothesis test to see if the same average is going to be if the average is going to be the same or if it's going to be more or less next year, that would be inferential. But since we are simply reporting 75%, that number 3 is actually descriptive statistics. And finally, number 4. In a recent survey, 67% of students stated that they have Pokemon Go on their mobile devices. And again, that's simple descriptive statistics. It was fun, eh? Nice and easy exercise to start off with. So, data or datum is a single observation, and data is what we speak about commonly. Let's just go through that definition before we start anything else. A variable, data is a variable or a characteristic of interest. And so data everywhere. It's the characteristic that we are interested in studying for some or other reason. And the word variable is important there because data is something that changes. If it was something that stayed the same, we wouldn't repeatedly measure it. So we expect to see it varying, and that's why it's also referred to as a variable. And datum, of course, is a singular, and data is the plural of what we are going to be using in our statistics class. So before I end the screencast, I just want to recap the new and the old terms, just for the sake of finishing off nicely. A population consists of all the items or individuals in a group. A sample is a smaller set of items or individuals in the group that we're interested in, and we'll obviously use a sample to make an inference on a population. But typically we'd be interested in what's happening in the population, not the sample, but because we can't measure the entire population, we'll collect a smaller sample to make an estimate of what's happening in the population. And this next 2 words are very important, a parameter and a statistic. Now, a parameter is a data point or datum, a numerical value which describes a variable characteristic of a population. That's very, very important because later when we do inferential statistics, we're going to have to distinguish between parameter or statistic. The word statistic, on the other hand, is a numerical value that describes a variable characteristic of a sample. So these two are related. They're cousins, I'd say they're close cousins, where the one belongs to the population, a parameter belongs to the population, and how I remember it is parameter starts with a P and a population starts with a P, and a statistic belongs to the sample. And also simply, statistic starts with a S and a sample starts with a S as well. So I think that was quite enough for our first screencast. Thank you so much for joining me for this one, and I'll be looking forward to catching up with you in the next one.